Hooke's law states that when a spring is extended, the extension X is directly proportional to the force F applied until an elastic limit is reached. If X is equal to 9 centimetres when F is 27 newtons, find the formula for X in terms of F, the extension X when F is equal to 10 newtons, the force F newtons when X is equal to 12 centimetres. So let's just have a look at this. So here we have two side-by-side springs, and we will make this live, so they're now moving. You can now see them slightly moving. If we right-click here and look at the material, and let's move this over to here, and if we increase the mass, now if we increase the mass of this one here, what we are doing is we're increasing the force on it, and let's just increase the mass slowly. And what you can see, of course, what happens is that the spring extends, okay? Obviously we get some oscillation because of damping, and that's what's happening. Okay, we get a little bit of oscillation. So if you pull it too far, you know that the spring will break, and that's what we mean by the elastic limit. But we're not interested into that, we're only interested up to the point where we get to the elastic limit. And what we're saying is that the extension is so the extension is from here to here, is proportional to the force applied to the spring. So this is an example of direct proportion. So what we're saying is that X is directly proportional to F. So if we were to draw a graph of X against F, then we would say here we get a straight line graph, therefore X is proportional to F, and remember it's similar to Y is equal to mx, where m is the gradient. Then to get a formula, X will be equal to Kf, where K is got a constant to be found, and it can be found if you know a particular value of F with a particular value of H, i.e. you can find the gradient of that line. So X is proportional to F. X will be equal to Kf, where K is a constant. When X is equal to 9 centimetres, F will be equal to 27 newtons. We're given that in the question. So, looking at our graph, we've got here, this is 27, going up to here, and then if we read off here, this is 9, so this will give me this distance divided by this distance, the gradient of the graph, and therefore substituting into our formula, X is 9 is equal to K times 27 is F, therefore K will be 9 over 27, which is equal to 1/3. So my formula is going to be X is equal to 1/3 of F. So X is equal to 1/3 of F. Right, now using that I can now answer some questions. So B, using our formula, when F is 10, X will be 1/3 times 10, which is 10 over 3, which is 3 and 1/3. So when the force is 10 newtons, the extension will be 3 and 1/3 centimetres. When X is equal to 12, we've got to find the force, which will give an extension of 12 centimetres. So we've got 12 is equal to 1/3 times F. So this is like F divided by 3. So if we multiply both sides by 3, we're going to get that F is going to be 3 times 36, which is 36. Therefore, F will be equal to 36 newtons. So this has been a video to show you how to use direct proportion in relation to Hooke's law. I hope you've understood, and I thank you very much for watching.